and we will have the last part for Q&A, and we will go through the DENPAFLUX platform a little bit so that we will enjoy a real demo about it, real life demo. So let's start. First of all, the EMC challenge or the EMC problem. So the question is there really a problem? Yes, it is, because there are a lot of manufacturers, there are a lot of hardware manufacturers out there that are still struggling with EMC. And it's not only a sentence, it's not only a saying, the numbers are there. So we know that 70% of the products going to the lab for the first time, they fail the test. So that means that out of 10 times you go to the lab, 7 you fail. And that means that 7 times you go home to tell your manager that you failed the test. And that in the end, that has a huge implication. So in the end, there's a lot of money that you need to spend to solve these problems and to go back and forth to talk to people and to redesign. And the problem is that one of the main bottlenecks is the EMC expertise. So there are not so many EMC experts out there, or there are not so many EMC experts available. So that in the end, that makes that from the moment you need an expert to the moment you get one is at least 4 weeks, or an average time of 4 weeks. So there is a huge problem there. And what we will see today is how we can soften that problem, or how can we make it easier for you, your managers, your company, and the product you are solving. So we know that EMC is hard. We all agree that it's hard. It's a problem. It's not an easy problem. As Raul mentioned before, it's something that we don't learn at high school. It's something that we don't have a master of EMC. So then that means that we go out to the market and we don't know where to start. So so that being said, the second question is, it's always the same part, or there are easy EMC problems or and hard EMC problems? So before panicking and telling all your team that there is an EMC issue, that you failed the test, that the world is ending, so make some questions. So start writing down, so how many tests are failing? Is the product failing just 1, 2, 10? That bring the big picture, not only the small and the close picture where you have a peak over the limit and then you say, oh, the world is horrible, I failed everything. Also, how severe is the failure? So are emissions 1 dB over the limit, 10 dBs in? So how often does that happen? At which stage of the product life cycle you are? Are you at the prototyping phase? So when you are still doing trials and errors, where you are prototyping the firmware, where you are checking different radio frequency modules, or are you already in mass production when you have already sent to the PCB manufacturer an order of 5,000 units? So of course, the impact is not going to be the same in one situation or the other. And the the last one is, can I solve the problems only looking at electronics, or do I need to talk to 1, 2, 3, 15 people? So all these are important questions that you need to make yourself, and so that you can state how big your EMC problem is. So let's see how we can rank EMC issues. So even if it's not going to be an exact science, it will give you the direction the direction and a structured process to see what are the next steps you need to take. So first of all, related to the test, I was saying how many tests you failed. So you have a bunch of tests, and so from emissions, immunity. So here, it doesn't make any sense to bring a ranking on which test is more difficult to pass, because it will depend a lot on the system. What I can say here is that the effect of failing all these tests is accumulative. So it's not the same thing that you fail just radiated emissions and nothing else, rather than to failing radiated emissions and immunity and ESD. So for this metric, you need to see the total. So um so yeah, and then let's go for severity. How severe is a problem? So there are some times where you have an EMC problem or you have a peak over the limit, but it doesn't have any impact at all on the system. So like the system is working perfectly fine, that you see absolutely no difference in the way it works. So in the end, here what we are seeing is that the system or a system that is not compliant with regulations because you are demanded to have emissions under the limit. So in that case, is what you need to see is that you are not going to be compliant with regulation, but you are able to move in other directions. You are not going, so your software can be still developed, your mechanics. So there are things that can still go. Another situation is when you have a moderate impact. So for example, so you have a display and sometimes it resets himself or but it's not always, so it's only under a specific situation. So there already you need to start thinking about taking some more dramatic actions, but still not very hard reactions because there are activities that can go. And then we have other situations where you have significant degradations. So where the system never works, for example. So when you are in a specific operation mode, and then the system starts resetting itself, so there's no way to use it. And the last situation, which is the one that we always want to avoid, is to have the system destructed. So, for example, you have a motor controller, you have a motor or an inverter, and when you go to high the maximum power, the maximum current rating, then there's a destruction of the control board. So that means that for every test, you need to replace all the parts. So seeing that, it's not the same to have a low severity than a high severity problem. I have seen a hand raised. I don't know if that was intentional or not. So I'm not seeing anything here in the chat. So I will just continue.
Yeah, Ignacio. I think it was initially, but not now anymore.
Yeah, don't be shy. Related to the timeline. So it's not the same to have a problem when you have just manufactured your first batch of PCBs or systems, so that you have time and space and components to add to the system, so to reduce emissions or to add some protections. Then when you have a system that is deployed in the market and there are hundreds or thousands of users using the system, so it's clearly not going to have the same impact. Here, of course, recommendation: start as soon as possible so that you don't go to the right area. And here, when we talk about the impact, so when you are talking, so when you are thinking about DMC, so on one side, you are going to play with time because anything out of the plan is going to cost you time, but also cost not only on material, but also on people, on time, on extra people that you need to pull to the project. And also the impact, you need to consider the impact on other parts of the design requirements. So if you add a filter, you are going to increase size and weight. If you increase or if you reduce, the switching time of a converter, probably you will reduce emissions, but you will increase losses and increase temperature. So that's something that's the price that you are going to pay. And also software. So if you need to add countermeasures on the software and you need to start developing new software, that's something that you need to consider. So don't forget the costs that are provoked by the extra time you spend solving these issues. And the last is that EMC issues or EMC requirements can impact also safety. So safety of the system, safety requirements, and that means and safety is something that is not negotiable. So you cannot reduce emissions by increasing the risk of electrocuting your user. So that's not going to be possible. So here, when you are balancing your trade-offs, you need to look always for the non-negotiables. So what are the things that you can definitely not move, and what are those that can be shifted in the project? So let's go a little bit more on the impact. So as I was mentioning, so anytime that you have an EMC problem, you will always need to spend time because there is always a surprise. There's sometimes some tests, some extra tests that you need to make. When you fail, you need to be, or you want to be extra sure. So you repeat the test just in case you made any mistake during the test. So all this is going to take your time. Also, so you are going to ask your colleagues to make a design review or try some new components, some filters, some protection, some um, copper tapes. So you are going to make a lot of trial and error, and this is going to take you time because in some cases you can solder the components directly. In other cases, the components are so small, so any prototype or any test is going to take you a few hours. In a worst case, you are going to redesign your boards or your systems, the cables, the mechanics, the thermal. So and this takes a lot of time. Consulting, if you pull external experts, so that you need to find them, you need to look for them, interview them. So that takes you. It's going to take you a lot of time. If you go to a new lab or you go to the same lab but in a second iteration, so you are going to pay more for the lab, and the cost of the lab is not small. So it's definitely something that you need to consider. And that to in the end, so you need to add so that every extra test that you are doing is time that you are not working on a new design or a new project. So the time that you are traveling to the EMC lab. So in some cases, the EMC laboratory is very close to your place. In some other cases, you need to travel. So all that time is going to be expensive. So solution looks easy. So it's planned for EMC problems. And how does it happen that we always hear people saying, hey, you need to plan for EMC problems, and at the same time, we are still seeing that 70% of the people go and fail. So how does these two concepts link? So the question is, why are we so bad at planning? Is because we have studied that, right? So we have read a lot of books about planning, project management, risk management. We have seen so we have gone through many resources saying how to plan. So how does it happen that in EMC, specifically on EMC, we are so bad? And the answer is kind of straightforward. So it's we are humans, and as humans, we have what we name bias. So we are not perfect. If you think that the reality you observe, you perceive is objective, is that's not true. So let's go through some examples. So we have what we name the optimist bias, and does that mean? Is as designer you fall in love with your product, with the work that you have been doing for many months. So you think, oh, my design is amazing. I have read so many application notes, so many books that it's not going to fail. You have also the sunk cost fallacy. So when you have a problem or you have invested so much time working on something, that the next problem you are going to face is not going to happen. So you spend 2 weeks solving an EMC, so an emission test, conduct emission. So of course you think that the next test in your list is going to pass first time. Well, that's not happening. So once we are there, we think that if it happened once, and if in that that time went well, so the second time it's going to be same well. So when we think, okay, we have a motor, for example, that works well in operation mode A, and then it passes all the tests, then of course in operation mode B, C, it will pass with no issues. So that happened for me to be, for example, in one product, it was a three-phase power supply, and the system was kind of symmetric, and was kind of symmetric because I thought it was symmetric. So I said, okay, I should measure conducted emissions in just one phase, so the other two will be exactly the same because it's symmetric. Oh, surprise, when I passed the emissions in one phase and failed miserably in the other two. Also, this happens a lot. So today, for example, when we are seeing a lot of designs that are being a modification or a subsystem of previous designs. So for example, when you are dealing with component obsolescence, so that there are designers um, replacing components by similar ones, or by components or systems that are very close to the first one, and then they say, yeah, the previous system passed, so then this second system will pass too. Well, it's not really true. And this, the last one, the authority bias, and this sounds very complicated, but I'm pretty sure that you have been there because I have been, which is trusting blindly a senior guy and not having the energy or the willingness to fight with a senior guy or a senior person, and also to trust what passed in what happened in the past. So my colleague senior told me that all the systems, that all the tests will pass with flying colors, and then in the end, what happens is that only just one test is fine, and all the rest fails. So failing at planning is very common, and here, so today we are seeing one example. Imagine that you need to go to the lab to do some conducted emissions, and then you make your calculations between the operation mode and the frequency sweeping, so that in the end, you know that you will need more or less, so roughly 8 hours of testing. So then you tell your manager, hey, Mike, the test, so it's going to be 8 hours. So basically what you are telling him is, okay, I will do just one day of laboratory. So then he makes the purchase order, he sends the PO, and then it's one day of lab. And this is what we plan, and this is what we think that it's going to happen. The problem is that the reality is something like this. So first, if it's our first time in the lab, it will take some time for sure to find the lab, because it's normally in a lost area of the city and industrial. So you need to find the correct person to unload all your material. So it's not that straightforward. Later, so you need to unload your car or to take all the materials. So so that you need to connect. You need to connect the power communications, and realize that you don't have a cable that you thought that you were not going to need, the debugging system. So it's not 5 minute task. Normally it takes some time. Also, so once you are there, you have been struggling a lot already in the morning, so you go for a coffee, also because the lab technician who is going to help you with the test, taking a coffee. So it takes, so it's totally fine. So before you start the test, you need to be prepared. Then you do some testing, let's say 1 hour, 2 hours, and then of course you need to eat. So then you go for lunch, and then after lunch, you continue your test, but okay, you have been like 4 hours testing, 5 hours, no more. And then later you need to ensure that everything is safe. So you disconnect everything. And if you have booked just one day in the lab, so you need to disassemble everything and load your car. So in the end, the 8 hour day is not at all the 8 hours testing. And this is totally normal. So it happened to everybody. The only thing is that you need to consider it when you plan your days. And this is just one example, but you can easily extrapolate this to all the single stages of the EMC process. And please, I know that what you are thinking, that you are the best designer EMC person here in the room. Don't think that it will not happen to you, because you are not immune. You are humans, and this is happening all the time. Great. So I'm for a poll. Let's launch. Let's share your experience. So please let us know if this sounds familiar to you, or it's completely new situation for you.
And Ignacio, is this poll related to the bias you asked? So I feel like this poll is related to usually what bias people fall in, you know? Okay, everyone. So,
Yeah.
so you will see a quick pop-up on your screen where Ignacio recently talked, and you can fill out which bias you usually fall in. I would be curious if it's
Okay.
Ignacio. What do you think? Well, where mainly people fall into? Because I feel like my bias would always been in my previous life was my senior told me to make the system. I was always have to do what needs to be done rather than going with that. But I will be curious what others think.
Yeah. So I mean, I've been through all of them. So
Oh,
and but it's true that I think that one of the most disappointing one is the senior. So it's the authority bias, because you take that person as a mentor, you take that person as the person who is guiding you. So you have been following person since a while, and and then when you go to the lab and come back and realize that you failed a bunch of tests, you start wondering, okay, I have been following the right piece of advice, or should I start looking for a new way? And I think that it helps you to open your eyes.
that's interesting. And Ignacio, have you found any effective strategy when you're finding this pattern where seniors are trying to telling you this needs to be done? How do you overcome such situation?
Yeah, I mean, it's a tricky moment, because of course you don't want to be unrespectful, but I think so. What I have seen is something that works well is to ask them to explain you in detail the design. So to ask them, so to force them to explain you the nitty gritty details, like why you have designed this in this way, why what you were you thinking about at this time, so that in the process they see, and they tell you why why they took the decisions, and in this way they force themselves to slow down,
Yeah.
and also to understand or to review some past decisions.
No, that's a very valid point because I think when you follow up with next questions on the same topic, then you tends to force them that how to move correctly. Okay, that sounds good. So yeah, thank you everyone for putting the poll results.
Mhm.
And yeah, I will quickly share it so that everyone is aware that yeah, 42% mainly share the same pain, which is that senior told me. But I'm also interested to see that people also feel like my design is amazing. Because I always feel like as an engineer, you're never satisfied with what you have designed. So you go with either over engineering, you try to put so much of things inside to make sure nothing fails, or you are under engineering. So that's really interesting for me to know that it will not fail. And yeah, what I'm curious is that in operation mode A it passes, and operation B C will not. So no one voted for that. That's also no. My plans are perfect. Yep.
Amazing. Yeah, thank you very much, everybody, for answering. It's very interesting. Great. Let's continue then to see how we can make the best DMC test campaign. In the end, it's how to make our lives easier, right? So we continue. So we're going to see a classical or a usual way of planning EMC. So imagine that you have a device, very cool device. It has some power supply. It has some radio devices. It has some PCBs or cablings inside. So then let's consider how people normally see road to compliance or certification. So they start thinking so about EMC. So they are aware that there is some preparation needed. Still, it's not super clear what's inside, but they know that there is something to do. And then there are a bunch of tests. So emissions, immunity, ESD. So it depends on the type of product. So the specific test change, but more or less this is what manufacturers see. So then once they pass all the tests, they think that okay, they will get the stamp compliance, and then from that moment they start making a lot of money. The problem is that, well, the first problem is that this process is never that linear, and second, that it is very often that they forget that there are other aspects of certification. So, for example, radio. If from the moment that you install a radio device, so you need to be sure that your system is compliant with radio regulation. So that means that you also need to prepare and you also need to go through a bunch of tests. And it's not only this list, but also there are other smaller tests or longer tests, and also depends on the type of radio that you are installing. So you need to get all the EMC, all the radio to start, so to get the compliance stamp or to be able to sign your certificate of conformity. And not only that, that you also need to consider safety. And safety also requires some preparation and also requires to go through a bunch of tests. So it's only when you have all these and also other tests or other documents prepared that you can get your compliance stamp or that you have everything you need to write your certificate of conformity that you can start selling the product legally in the market. So why I'm saying this is because planning for EMC is hard to do it if you don't have a high level view of what needs to be done. So common mistakes that we have seen in during the EMC preparation, during the certification preparation. So in my life here, things that I have seen in my life here at DENPAFLUX, but also in my previous life. So preparing just one sample. So it's very common that manufacturers get very excited with their device, so that they have manufactured one. This is the one that they are showing to customers. This is the one that they are showing to their family, and then it's the one that they manufacture and that they build for everything. So they bring it to the lab, they test it, and then problems come when they need to do things in parallel. So laboratories, EMC laboratories, if you ask them, normally they can run tests in parallel to save time. So that means that if you provide them 2, 3 samples, they are going to be able to run more than one test at a time. And that's very important because then the time you spend in the lab is going to be way shorter. And second is that a big part of the test is destructive. So by destructive means that if the system passes all the tests at first time, then okay. But if there are some problems, there will be part of your system that will blow up. So that will have some damage that will make the system completely unusable. And if you are in a certification campaign and the system is destructed and the EMC lab does not have any spare sample or any spare PCB product or any kind of a spare part, they will just stop. They will call you and they will say, oh, I cannot continue the test. And in some cases, they will charge you for the rest of the week. In other cases, they are more open to stop and then continue with other activities because they are very used to this. But we can be more prepared so that we make their life easier. Also, it's very common that we rely or that manufacturers rely in just one laboratory because they have some relatives, they have some colleagues that they have a good relationship with the laboratory, so they go there. So as laboratory by default. And the problem comes when manufacturers start building new devices, new products, like they start using radio or new power voltages, new power levels, sorry. So that at some point the laboratory is not able to accept your demands. And so that's why it's very recommendable to talk to at least two laboratories. So that also in the case that one laboratory is not able to serve you because they get sick, because they close, because they are moving, because whatever reason, you have always a backup plan. So at the preparation phase, it's always interesting, and it's always very. I strongly recommend to talk to two laboratories. And the last one is to not plan interdependencies. So as I have shown, we have EMC, we have radio, we have safety, and we have other things, other areas. And it's very important that you consider how these three areas can be interconnected. So if you are going to change a filter in the radio frequency area because you are failing radiate emissions, this is of course going to impact the radio testing. And if you modify the Y caps of the input filter, this is going to impact the leakage current of the safety test. So always consider these dependencies and and take them into account for the planning. Since we are talking about making your EMC life easy, one very important aspect of you as designer or as a person in charge of EMC is to keep people happy. So we usually think that the EMC job is a lonely activity and that you are completely alone in the project, that you should take care of everything and then don't not bother people in general. And this has a reason, and it's because so the EMC person usually is seen as the person who bring bad news. So it's always coming back with an EMC test report saying, "Oh, you failed," and also that it's the person who is coming to tell to hardware designers, those people that have been working very very hard on their designs, that they love it so much, that person is coming to tell them that the product is failing, that it's not that good, that it's not good enough. So people feel attacked. So there are ways to reduce the impact or to reduce the bad reputation of being the bad EMC guy. So it's always recommended to keep communication open. So from the moment you start testing their system, send them emails or involve them so that you tell them, hey, I'm doing this because of this, that, so that they know why you are doing that. And also make them questions. Hey, why did you select this filter? And why this not? And have you considered these different materials? So that you challenge them and they feel more and more involved in the process. That those two areas are not separated. So send them regular reports, screenshots, setups, so that they know what's going on there. And you don't need to wait until the end of the project, so that you can send you can start involving them at the very beginning. So when you know that there is a prototype somewhere there, take the prototype and take it with you and make some contact emissions, some near field probes measurements. So something to show that there is a direct correlation between EMC and design. And what is the impact? Because in this case, so I have seen a clear change of behavior. Is that people are very much less disappointed, so that they feel that we are more a team and not just a random EMC guy who comes with bad news, and also that they feel included, so that they don't feel like that they are the bad guys, the bad designers, but that they are also part of the process, and that's very important. So with a few tricks you can keep people happy and also you, because it's not always good to feel that you are always felt like the bad messenger when you enter a room. So keep people happy. That's very important. Also, don't forget to keep yourself happy. So I know that the world is about others, but you don't need to forget yourself. And as a person who has been in different test campaigns, I have seen a huge change from moving a more chaotic and reactive approach to a more proactive and very detailed approach. So, for example, I used to be like this. So I used to take notes, or not even that, that were very rough and very fast. Okay, I go to the lab. I have seen and so peaks. I added some copper tape, and then okay, ciao, see you tomorrow. And the problem with this is that 2 weeks later, I had no clue what I was doing there. So I could not tell anybody what was the process I was following, and not able to replicate the process a few weeks later. So a big difference is when you start detailing every single step of what you have done so far. So detailing operation modes, detailing the margin, the DBs, so the distance, everything. Like even the breaks, so that you know um, that there is a correlation between the time between consecutive tests and if you were doing things correctly. So staying organized does not cost so much, and it will save for you extra visits to the lab. So then to wrap up, so if you want to have a happy EMC roadmap, plan always for inconveniences, and please don't tell me that there will be no inconveniences, because you cannot plan for a perfect setup. So add always buffer times for every single activity you do. Prepare spare parts, and I am talking from about PCBs, systems, or even screwdrivers. So don't trust that the lab has everything you need. Talk at least to 2 laboratories, and keep your communication open. Always involve everybody, and please take your time to organize your information.